G'day guys. Done some extra work on this GPX 5000 and it's going to be quite good. It's going to be quite good. We've tried to get rid of a lot of the hold-ups for signal processing in the detector, and we've improved the ground balancing, and we've improved how fast we can clock it, and we also have improved the whole front end design. If you ask me, my opinion, it's my front end design. I think it's better than what was in there. Well, actually, technically it is. And if you can see this detector there, I've got it on the highest clocking frequency. I have it on fine gold. You can see the waveform on the oscilloscope there with the little small pulses. That's fine gold. I've got this one all factory default settings except for manual tune, which we have turned into variable frequency. It's up at 255. That's the highest it will go. So at the high end, it's made for very, very tiny gold. And if you drop it back to about between 136, 128 in that area there, it's basically stock standard normal waveform you get out of these detectors when you get it from the factory. So if you want to look at it that way, and then we can stretch out the pulses if we go lower in frequency, and if we want to go and get smaller pulses, as long as the detector will do it. But you've got to modify the detector to do it. Otherwise, it'll desensitize. It'll just jam up its own, whatever. And it won't allow any detected signal to pass through the circuitry. It'll just be gummed up. So this one here's been done. Now, I did say it's in boost audio, just because the signal levels, the whole thing's very quiet. My amplifier's flat out, right? That's how quiet this detector is. It's just a little bit of noise. I've got the heater on, got some switch mode power supplies on and stuff. Even the oscilloscope will make noise, believe it or not, on these detectors. And on the coil setup here, if you can see, I put a bit of tin-plated wire underneath my tray of magnetic ironstone. And when I say it's magnetic, I can go and stick magnets to that all day long. And it's really, really the worst stuff you could ever find to detect on. You'll never get it like that, like a gravel. It's just pure ironstone. There's no dirt in it whatsoever, which I showed on the other video. Anyway, the main thing is here. We've got this in fine gold. Fine gold is the first mode on these detectors that if you turn things up too far, it will desensitize, especially on really hot ground. I could go back and see if it, I need a standard detector and totally unmodified and try it the way I've done it to see if it gets affected. But this is really hot. This is like mega hot ground simulation. And yeah, I mean, I could put it right on that ironstone, but that's asking too much. That's too much interaction directly on the coils. So, you'll never find that out in the goldfield. It's just too much. So what we've done, we've gone for broke. We're going to say these detectors will handle no matter what you throw at it. Now, it is ground balanced as far as I remember. What I can do, I can just pick the coil up. Now, I've got another hot rock there, so I'll get rid of that. What I'll do, put it in the fixed, throw it into tracking. Give it another flick. Okay, highest frequency and a massive mineral load on the coil, and no problem tracking at the highest frequency. And these coils are nothing like the coils you will find from the likes of Nugget Finder and even MindLab. They're very, very, because they're wound very, very tightly, they've got high capacitance, which is also a detriment as well. The bigger coils, because of the winding spacing and less turns, you have less capacitance. You can make them less capacitance by spacing the windings. With these, I mean, you'd end up big, thick coils like that, and it's, you know, it's not really efficient. It's not for doing testing anyway. So first of all, in fine gold, we'll try our trusty old 0.05 gram. I'll get round the other side to do this. I've got a whole heap of stuff on the floor in front of the tripod and I don't want to step on it. So 0.05, and I might even, just before that, yeah, I've got to put this up here, otherwise you won't know any yardstick measurements. Hang on a sec while I do this. I'm going to put that there, and I've got to put post-it notes. There's my post-it notes, and also that. I think I need both. Let's go a little bit of a forward lean, which might help on the camera actually. You can see that. Okay. Now, I'll get round to my hot rock collection. Now, if we have a different type of hot rock, like these are ironstone, this all comes from near Great Western, which is halfway between, basically, it's nearly up to Stawell, but you could say it's along the road from Ararat to Stawell, and in that area there's a massive area, and these have all been sorted out with a magnet, of course, so they're all totally magnetic, and it makes one of the worst things to try and detect on or try and ground balance. Anyway, we've got our other hot rock here. Okay, now as I'm going to keep walking around the back of the tripod, I'm going to flick this from fixed back in the tracking. I'll give it one more flick. Hang on, let's get that out of my hand. Okay, fine gold, absolute cranking, right? And we can get rid of hot rocks on a pile of hot rocks, basically, on a pile of reactive ironstone. So the detector is running beautifully. If it does it in fine gold, it's going to do it in every other mode too. It even tracks out normal. Work that one out. So a lot of very interesting issues in these detectors, trying to get the speed up on them, has been overcome. It's all worked out and it's working beautifully. Now, I'll leave this in fixed tracking just in case we start tracking targets out. But anyway, 0.05. And I might turn the heater off here. It's making it hard to hear. I can hear that getting up round about 8, maybe a little bit higher. That's a tiny target. You know, it is a big target really, because how sensitive this detector is, the way it's working. And if you had a pure mono, not transmit and receive sitting over there, well, basically the cancellation for the other channel, this will work far more efficiently. This is a good test setup, but it's not a good detecting setup. Yeah, I can get up around about 8 and then it fades off, which I would expect. If we use the 0.1, something like that, I mean, it's going to blow your ears off. Just a 0.1. We're up around 10. That's 10 centimetres with a 0.1. But the big trick is we know we can ground balance everything. No matter what you throw at it, it'll ground balance it beautifully and be very, very stable on the ground balance too. There was another target I want to test. We'll test the tiny, oops, ran the wrong way. Paint's fading off, or the pen or whatever. 0.0025. 0.0025 of a gram. I mean, that is just microscopic. Anyway, because of the improvements we've done on this detector, like I said, never stop innovating. Innovation will get you more performance every time. So it's very soft. We can't get it up as high as a 0.0, whatever it is, 0.05. Just to show there's nothing up my sleeve. So that, actually, let's just see how far I can get it, because I haven't actually measured it. I don't know. You know something? I'm completely, am I doing this? No, I suppose, because I'm measuring to the top of the coils. I suppose it's, we can call that accurate. Normally we would put this down and have this level with the bottom of the coil. So it's actually probably working better than I think. I don't know, 4 centimetres. Remember before, I could get it like this. Had to get it somewhere there. It was about a centimetre or something. Now I get up at 4. What's that? 80% improvement? Crazy. Yeah, at 5 it gets really wishy-washy, but you can get it at 4. I mean, yeah, I think that's pretty good for a pulse induction detector, that you can actually adjust it to get signals like that. So I'll stick my buff head in the way, and something like a ring. If I lowered the frequency down, that would be far better than whatever it's doing. It's up around, you can't see. Oh, dear me. And fine gold's not made for big targets. If I put that in normal mode, it'd be bloody booming. But anyway. At 37, 38, puts out 38. which is probably one of the best measurements I've ever actually had, especially using those very fine gold modes. It'd be interesting. I just put this into normal mode and see how it goes. It could be very, very interesting, but yeah, I'm not going to worry doing it because I just know it'll work really well. So that's that, and that's that, and there you go. We're still in fine gold. So what I actually no, yeah, I can do it. I think I would like to know what the difference is, like I've said many a time, between sensitive extra and fine gold on small targets. I'll put this into sensitive extra and we'll try it and just see what the comparison is to fine gold. Even though there goes the drill. Okay. Where are we? I'll still keep it up at 255. Special, fine, sensitive extra. We will want a ground balance again because different mode. And I'll just, and you can see the timings there. It's jumped into sensitive extra, but basically it's in normal time, normal timings. The rest of the sensitive extra mode is done in software, and it basically receive turn on timings, dead time, transmission, pulse length, whatever else. I don't know what the variables are there. I've never really worried about it. Okay, can we ground balance? Well, I haven't done a fast track. I'll take that off because we'll go flying. We'll see. Basically ground balance. I think I'm banging all the wires and those clips there. Yeah, need a cameraman. Yeah, when I'm banging it up and down those clip leads, it's probably detecting them, but it does ground balance out. Yeah. Now get these centered up. They're sliding all over the place. I think I'll give it a quick flick. I have to get in front of the tripod without stepping on stuff to do this. Okay, and then into fast track. Basically, told you about stepping on stuff. Okay, so it has ground balanced out. So we'll get the other nasty hot rock and we see if we can get rid of this with that, because everyone tells me this is a mode that's very, very susceptible to hot rocks. Might have to give it a quick flick to get the fine ground balance. See if it'll do it. Basically gone. A little remnant there, but I mean, what we're already got sitting there, it's a massive bed of reactive ironstone. I'm going to get out of here. Now, I want to get the tiny target and just see where it compares to fine gold. We have to put that back up. Okay, stay there. 0.0025. Now, sensitive extra is more sensitive than fine gold. I always said it was, and here's a proof of it. It's a definite 5. We're not going to do 6. We can do 5. So if you look at percentages, in fine gold, you're getting at 4, you're getting at 5, 25% increase. 1 in 4. So basically the same response close in and in the coil, like in the coil. But because the detector is so quiet in the electronics, it's very easy to hear. Yeah, it does pick it up at 6, only on a couple of swings. So very, very tiny little targets. The other thing to do, we checked this on a bigger target, which is that ring, which I was getting up around 37, 38. The only thing is, where'd I put it? Hang on a sec. I must have walked around and put it down somewhere. Looking. Where'd I put it? That happens when you have a lot of stuff all over your bench. And that one. I think it was that one I was using. I have 2 of them. This one's got knurling in it. The other one hasn't. But anyway. Hang on. I've got to put the camera back up. See? Need a cameraman. Maybe, guys, if you get bored, someone one day can come around and help me. Still got that cough. But, okay. I think I'm actually tracking the target out. Hang on a sec. I should have put it in fixed because I had fixed on the other one. Well, I think I'm getting very, very iffy. This is what is interesting with these detectors. You can track targets out. You really have to try hard to do it, but you can do it. So what I'll do, I'll just make sure it's probably out of ground balance now. No, not really, but I haven't even. I forgot to screw up the lead into the detector too, so I'm knocking it as I touch it. Okay, we were a little bit out, but it's no big deal. At ground balance, I'm going to put this into fixed. So we're in that ground balance set, exactly the same as what I had it before. Anyway, we'll see how we go. Helps if I swing over the coil. I just realised I wasn't. About the same as fine gold. It's very, very subjective to what actually sounds better. It's just iffy. So that's where we are. But what gets me is the sensitivity, which you can't see because I haven't adjusted the camera. The sensitivity on these things. I've locked the ground balance, like basically hard up on all that and the hot rock. So yeah, try doing that with your standard detector. Right? That's a bit of a joke. I don't know. If I could actually get the 6,000 to operate, well, you know something? I could actually do this with a 6,000 as long as I pulled apart a genuine Minelab or dongled coil, took the dongle out, connected it to the transmit coil, and then fed the receive coil in antiphase back into the 6,000, I would then have a cancel mode. You could do that. So you'd have to obtain some cable and yeah, completely destroy 6,000 coil doing it, but you could do it. You get the bloody stupid idea, if you ask me. For my opinion, having dongles in coils, you know. You know why dongles are in coils, don't you? It was to stop the Asians, and it was also, I think it was aimed, in my opinion, to stop X coils over in Russia or Belarus, wherever they operate from now. And that was the aim of it, to cut them out of the market. But as you can see, everyone's busting their proverbial trying to get around that issue by pulling things out and putting them in. So, yeah, I don't know. Where there's a will, there's a way, isn't there? So, and just for the hell of it, I'm going to shove this into normal mode. I mean, pure normal mode. So, go up here. Okay. I'll flick it into... You know, guys, none of you detect in normal mode, do you? Because you don't want the big gold. But anyway, let's go. Okay, flick. Well, we'll go into... Let's go into fixed. Don't worry, I'm not going to... Look, normal mode just chewed all that up and said, oh, I'll balance on that, not a problem. So, that's a massive improvement for normal mode. Massive. Normally you just scream and scream and scream and scream. But can we get the tiny little 0.0025 in normal mode? Oh, holy hell. That's amazing. Actually, I'm going to measure that. Because I've got all this bolted down now, I can keep it as a fixture. So I could do comparisons very accurately. I don't have coils wobbling all over the place or sliding around. Okay. Then I'll get down. So I've got to line up with the ruler. It's a smidgen under sensitive extra. It's about 4.75 or something, and a rough guess. Actually, if I go very slow, I can get it at 5. Whatever that's set, I think it's set at probably like a medium tracking speed. It was in factory default, and I've just adjusted the manual tune to put in high frequency. So on that is working really well. But the thing about normal timings, I put the ring in my pocket this time, I'm not going to lose it, is really, really good on bigger targets, as we all know. It is thumping out a lot of transmit energy. Hang on, I just have to adjust this. So the ring. Itchy throat. Dear me. I'm going to have to cut this a bit short, I think. I'm going to start coughing. I'm going to go into a coughing fit. No, it's a real scratchy, rotten thing on the side of the throat. Make tears come out of your eyes too, rotten thing. But yeah, here we go. Getting up around 37. But this is what happens when you optimize your detector for very, very tiny gold. How about I just tune the variable frequency? Oh, yeah, variable frequency. Well, that's what the manual tuning is now, variable frequency. Yeah, don't mind me, I'm slightly falling apart. Jesus. So getting the right menu. Yeah, it was in general ground balance. Manual tune. I'll just turn this down because as we change the DC levels on the capacitors in the integrators, it'll scream. So, oops, turn the wrong knob, silly me. Okay. Oh, dear me. 144 on the frequency. And we're gone out of lock on the oscilloscope. Oh dear, hang on. Drop it back. There you go. Oh dear me. So I've dropped the frequency back. It's somewhere about half scale. 146 or whatever that is. So what we'll do now, we're still in, I should really ground balance it and so forth, but hey, this is not going to be nothing in it really. We'll see what happens. Lower frequency for bigger targets. Smaller targets, higher frequency. That's the way it goes. I can tell that's got more punch already. Over the top of the ruler, over 40. Now, a ring is not a very big target, but it does make a difference. Even so, we've dropped the frequency. We've dropped it quite away. We've we've lengthened the transmit pulses. We've lengthened the receive window, but we've also opened up the dead time between the two, which normally would be, well, basically that's a negative on very small targets. It doesn't matter that much on really big targets. I'll let you know on that. So what happens, we get our little tiny speck thing here, and now I'm pointing up in the air again. Good. Come on. wish this thing could read my mind and self-adjust. That'd be good, wouldn't it? Okay, now this is normal mode, medium frequency, not high frequencies or low, but in the middle, right in the middle. As you can see, the response on that drops off, but on this, it comes up. The ratio of the transmit, pulse, receive window, and so forth is critical. You can't have it all in one detector. On Minelab's detectors, as you may be aware or may not be aware, that they try and put in different pulse lengths into their chain of pulses. So some is better on bigger targets and some is better on small targets. But to get optimum performance, you need the same lot of small ones or the same lot of big ones, because you've only got a certain time period to get them all in. And you know, your overall amount of time until it starts again before the receivers turn on and turn off and everything else. You could have a big pulse here, a little pulse there, another little pulse there. You probably got to put your ground balance pulse in too, which is usually a big long one. And you can only get so much in that time window. Whereas you're using lots of small ones, you got all small ones, very sensitive in that time window, lots of samples. You have big ones, or bigger, you still fit more bigger ones in that time window. If you have big, small or something, you only got two small samples and two larger samples. So everything's a compromise, in my opinion. So what happens if we go right down low end frequency? I'll turn this around so you can have a look at the oscilloscope as we go down in frequency. You'll see everything there move, stretch out. Ah, damn, hey. No, I'll probably turn the wrong one. No, it's that one. Okay. Now we're at 140, it was 146. I was down to 142. I'll do this. I'll turn this down because it's gone out of lock, but you can see them all moving down. There you go. We're on 0, right? Now that would be huge, big pulses. Go on, lock your sod. These oscilloscopes hate mixed signals and mixed pulses. They go, oh, what am I going to lock on? I'll lock on that. Oh, you moved it a couple of, microseconds. I won't lock on that. I'll lock on this other one, and it's all over the shop. Can we get small gold on the lowest frequency, where this would be set up for the biggest, deepest gold you'd use a massive big coil for? This, where it is now, you'd be using 20-inch, 25-inch monos. And even the big 25-inch double D will work beautifully at lower frequencies, as long as you're targeting larger gold, which everyone else has walked over, by the way. Anyway, I won't go into that just yet. So, can we still get tiny little gold? I got to turn the audio up again because I forgot to, didn't I? Okay, we'll go back to how we were, and even though the ground balance will be way out because I've gone down frequency. Every time you change frequency, you've got to read ground balance. I haven't done it, it's in fixed. But anyway, we've lost another 25% performance on that very, very tiny target, okay? Because we've got the frequency set low. It's not optimized for tiny gold. You go up the other way, it's optimized. So really what you want to do is you want to say, I'm looking for this sort of gold. I'm going to use this particular size coil, and then you optimize it to what you're doing. Realistically, you can use a very small coil, you can crank everything flat out and you can lower the frequency if you've got really, really bad reactive ground, right? Which I'm compensating for that anyway, but I mean, if there's worse ground out there in the world, you can lower the frequency and open up the dead time. So you're going to get the remnant decay disappear. And hopefully you still have a target signal there. But small gold's not optimized for that. But it will work with a small coil. You can mix and match. I think I have to actually do an article on frequency, mode, coil size, and the reasons you do things. But anyway, we're still on normal mode, normal timings. We're at the lowest frequency. It's probably too low for this ring. This when I've got it set now, it's looking for something like that. It is optimized for something that big, and it will ignore a hell of a lot of ground noise. At low frequency, the dead times spread out, so there's a greater amount of time for any ground noise to dissipate before you hit the target signal from a big piece of gold. And a big piece of gold is going to ring like a bell and continue reverberating. It doesn't really reverberate. I was trying to say it in a way people will understand. If you don't understand the electromagnetic decay, that it continues making a noise, and then when the receiver turns on, it's still making a noise, and you hear it. Right? Sort of the same thing, but yeah, reactive ground. If certain minerals are in that ground, it will have different decay rates. So I want to go back up now. This is on 1. This is very low. We'll see what happens. Wow. Can you hear how much punchy that is? Helps when I go over the coil again. I keep getting too close to the ruler. $39, okay? So we've increased our detection depth of something like that. Now, imagine if you're running around with this and say, this isn't a really good indicator of what can be achieved. But what I'm trying to tell you guys is that you can go around in the normal operating timings of this detector. And in the middle of where I've got it, where it tunes, you've got just a general purpose setting. Where if you look at the transmit pulses on normal mode, they're about 35 or 36 microseconds length. Okay, we shrink those down and we expand those up, and it does it for all modes in all different things. And you've got to be careful when you do it. You've got to know what you're doing, else you're going to end up with problems. But as far as I'm concerned, all problems have been solved that were ever there. And basically making this type of detector, yeah, expert proof, right? Cranking it up too far and stuffing it up. So in that regard there, or can we, we can still get this. You're not going to get it up here anywhere. It's not going to be there. But, put the frequency up, it will. That's what I mean. When you go out looking for gold, what people do, excuse my croaky voice, what people do, what prospectors do, and what people who don't really know about all the little tricks of the trade, go over a patch of ground with a dirty big coil in low frequency. Go over it again in high frequency with a dirty big coil, right? Then go over it again with a medium-sized coil and either crank the frequency up or down. It was going to change the depth profile of the coil detector setup on the size of the nuggets and the depth, right? And then you go over it all. If you can do it the other way around, doesn't make any difference. Go over it with a small coil, right? At very high frequency and pick up all the pinheads or less. And then go over it with a very small coil and do it at a lower frequency where gold a little bit bigger than those pinheads, which are a little bit deeper, you'll be able to hear where you just normally just walk over them. And no matter what mode you're in, you'll probably walk over them. So you've got to look at the ground and you can say, okay, I'll first hit it. If you've got if just a normal detector, right, you don't need to adjust anything. Just away you go. You can't adjust anything. But if you're using a modified one with variable frequency, you can now optimize that detector to the coil and to the type of gold you want, right? And if you want to still do it all, tune it to 136 or something. That's right, bang, 35 microseconds. So we go lower, we go higher, right? So it's very, very simple. And you say, oh, I just want to be in standard MindLab, come out the factory mode, tune it to 136. I usually have 35, 36 microseconds around 136 on the dial. So if you want to know, and then you can optimize it up and down for whatever you're looking for. It makes a big difference. You see it make a big difference. Even here we're talking, an adjustment will make, over 25% difference. So that's why there's a stack of gold out there that no one's found, because no one optimizes their detectors and coil sets up and goes looking. They all just go, oh yeah, got a coil on the detector. Oh yeah, 12, 14. Oh, that sounds all right. Away we go, right? And I guarantee you're walking over nuggets that are probably another couple of inches down. You've got no idea they're there. The detector won't pick them up. So yeah, that's why I've done a lot of work getting the ground balance perfect and getting it so it does all gold, and it's got plenty of grunt. I mean, I can get more grunt out of these detectors, by the way, but there are there's FCC guidelines, emission standards that we have to adhere to. Okay, this is not allowed to generate harmful interference. So you got to check on that too. You got to have a look. And basically, I put this. I use the other oscilloscope. I stick into FFT mode and have a look at the spectrum up the band. Make sure everything's well within regulations. And the other thing as well, I'll tell you this. Say you've got a detector and you're going to tell everyone that it's a scientific instrument, okay? And you're going to test a scientific instrument. It's a one-off. Did you know there's actually no EMC limits for testing scientific instruments out in the field, as far as I know? I spoke to someone about this who's very, very, very knowledgeable. Believe me, they are very knowledgeable. And they concurred that there is no guidelines on emission for, as long as it doesn't go bring down, jam out transponders on a bloody 747 or something, that there is no criteria for that. So you could convert these detectors and up the voltage on the transmit. You can change the coil inductance. You can do a lot of things and get more grunt. You could it has been done. Jimmy Stewart was telling me that in the early days of SD2000, just before the SD2000, that they were running SD2000s on 12 volt and 24 volt. And he was telling me that he was using a detector on 24 volts one day, and he reckons about a minute into the exercise, smoke started billowing out of the detector. Anyway, and eventually, out of all that initial testing, they went down to 6-volt supplies, didn't they? So that's how that detector runs. It runs on 6 volts. transmit 6 volts voltage on the pulses. But you can, with modern technology, and there's different ways of doing it, which I'm not going to go on to because some of them are paintable, that you can do a lot more and get a lot more out of these detectors. Early on, probably around about 2000, I actually made up an afterburner for the older detectors. It wasn't these weren't around, GPXs. And now I'm going to turn off the audio. We'll turn off the detector. Just so you know, I run every detector I do testing on, I run it off a battery. And the reason I do that is because it simulates exactly the same power supply and the same basic setup rather than using something connected to the mains. It's quieter anyway. You get less ripple and stuff. But yeah, I made up an afterburner, and I was trying to make it a standalone that I could sync the receiver. It had to run in double D mode on a double D coil, otherwise it would have blown the credoodles out of the input amplifier on the detector. But I made this afterburner up, and I was running 18 volts. And when I running shorter, sharper pulses, yeah, I could actually do it. It would work. What my biggest problem was trying to sync back the receive pulses into the front end, not getting destroyed by transient voltages. And if you try to suppress it, a lot of cases that you lost some signal. So yeah, I did that. I tried running external switching MOSFETs and that, but you really needed so much stuff done that it looked like a bit of a monster detector. It'd have a big box on the outside, and I'd have to actually drill extra little hole into the detector, run a cable to run all the control lines to my switching circuits on the outside. But it can be done, right? It can be done. You could do it as a scientific instrument for experimentation. I don't know if you want to do that, but if you did something like that, you have to change your coil configuration. You might have to run a lot lower frequency, greater inductance on your coil, change the damping. A lot of things you'd change. You'd have to have pretty robust back EMF, or spike suppression, damping, all that have to be beefed up. But you could do it. I wouldn't do it for small gold. It's bloody pointless. But big gold nuggets, if you wanted to get down really deep, I mean, if you wanted to get down on something, I don't know, something the size of a can of Coke or something like that, use a big 30-inch coil, 30, maybe even 40, which I used to play around with that stuff. God, they went deep. And big, huge amount of energy into the ground. And you need a lot of dead time too, because it's going to energize the ground. It's going to cause a lot of ground noise. But you can do it. It can be done. No one's done it. Well, I've done it. I know early MindLab ones, they were doing it, but they gave up. But the technology probably wasn't really available to do it properly back then. Now it is. You could actually run the whole system via its own separate MCU on the outside of the detector, and synchronize everything nicely, and walk around with a car battery on in your backpack. Not that bad, but because we've got lightweight lithiums, you can get a lot of energy in a very small package. Before, we were using lead acid batteries. We're using fire alarm batteries and stuff like that, and they're heavy, and it's just what they were. Big burglar alarm batteries. We're going to call them the backup batteries. Things that are I don't know, about that big, and that, and they weigh a lot. And you got a couple of 12-volt ones of those, and you want to run them in series. You got 24 volts, but their overall current rating is not that great, and they go dead really quickly, and you put your back out. So lithium packs now, the only thing with lithium, you don't want to draw too much current out of lithium too, because it's friggin' dangerous. As soon as those batteries get hot, or you do anything to them, they will let go. So, got to be careful with lithium. Just, you know, it it's I don't know. I always think lithium's a risky proposition. Like I was saying in the other video about if you have your device on and the particular charger board in there, and charging at the same time, the battery um, charge voltage won't be regulated. It will go past the cut-off point and keep ramming that battery with current. Then it'll grow dendritic crystals, go high impedance, or the worst thing is that the anode will start generating oxygen, and the whole thing will go up in flames. So, yeah, like I say, is freaking people have these dangers of this stuff out there and don't know. The public don't know, and it's just sold to them. They don't know. So I don't know why there's not some massive crackdown on it. It's just so easy. Just go online, buy it from where, and it's on your doorstep, and you'll go, oh, beauty, we'll wire this up in my thing, and next week your house burns down. Fantastic outcome. Just because of, that I always say, it's like the 90% country. Everything's nearly there, but not quite right. It's getting better, but yeah, I still don't think having your car catch on fire, or your house burn down, or even your tent burn down because of that is acceptable. Anyway, I'm not going to keep talking. I'm going to lose my voice. But anyway, look, that's where we are with these detectors now. Freaking going like a house on fire. I mean, that is just awesome. And it hasn't even got the variable gain in it. So with variable gain, it gives you so much extra leeway to get more out of it. But the thing is, I'll tell you what, when I put variable gain in these, I really think I have to do an education course for every person one-on-one. But then I'd have no time to do any detectors. So that would all go out the window. But, I've written manuals in the past for these things, and I say, don't do this, and, don't mix that with that. And people ignore it. They don't read it. And then they're saying, oh, it won't detect. Yeah, because you got that up too far. And you're on this type of ground using that type of coil. So it's just education. So, anyway, that there, you can't stuff it up. That you can give that to a complete novice. You cannot go wrong. Except, if you just get the frequency wrong for the type of coil you're using for a particular type of ground. So, yeah, that's where we are. Anyway, I'll turn the heater off, and it's getting cold. Something probably about 5 degrees Celsius or something here. So I'll turn the heater back on. Yeah, that's probably what you can hear in the background if you've got a wide range speaker on your audio. You'll be able to hear that. So I hope that's a bit more educational on where things are up to on these. And I'll tell you what, it's exactly the same for the 45s, the same for the 4000s. I'll tell you what, right? If you saw how well that went, how good it went, right? And you look at the normal timings, right? It ground balances. You can set it up for small, big, whatever. Go find some GP Extremes and have that done to the GP Extreme. It'll be an absolute killer gold machine. People think that as the detectors come out newer and newer and newer, they're better and better and better. But maybe they are, but we can get the old ones and make them better than the new ones. We can. I've proven it. I don't know what else I can do. That'll work exactly the same out in the field as it works in here. What's the variable? Swinging the coil? Well, I've taken care of the earth field. There's no earth field residue. That's easy to prove. You just bounce magnets up and down next to the coil. It doesn't respond. It's not going to respond to the weak earth field. So all this stuff can be fine-tuned, made a lot better. And yeah, you think we're right at the crunchy end, pushing the pinnacle of it all? No, we're not. I've got some stuff coming. I've got some more stuff coming, which is going to be very, very interesting. I'm actually redoing, or I'm doing some board designs right now. So, and you may notice that when I do board designs, I do not have any of my stuff connected to the internet, right? It's separate. It's all separate, and there's no Bluetooth, no wireless. Because I tell you, some of the stuff I've done, I see very similar turn up, and it's always made me go, how'd that happen? But, especially with ergonomics, the shape of things. I'm not going to go into it, but yeah, it has. It sort of unnerves me a little bit. I say, it can't be that coincidental, especially 3 or 4 times in a row. But yeah, that's where we are with that. Now, what I'm doing too, I'm redesigning the boosters we're doing. I'm doing a complete redesign of those. I've got some more ideas. There's going to be a lot of R&D, experimentation. I've got some stuff. I've got stuff that I can go and launch commercially right now, right? But I just haven't got the time to build it. So that's a real problem. I've got some really good stuff, and I feel like because it's so damn good, and I'm not putting it out there, that I'm not doing the prospecting community any favors. Because I know it'll make you or get you to find more gold. It's some of the stuff is really, 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 really good, and I just can't do a show and tell now because what will happen is that we'll get monkey see, monkey copy, and that's exactly what will happen. So you do all the hard work and show it all off, and then someone will go and try and back engineer you real quick and beat you to market. It's happened to me once. I lost. On a design I did back in 1998, I suspect I lost probably $100 million on an idea because I didn't launch it into market hard and fast enough. I tried to do it on eBay, and all I did was get, the country that copies everything. That's exactly what happened, and just by sheer mass, I was swamped. I was swamped. Even though the thing they were selling didn't work, my one did. But the amount of advertising and resellers, and the whole thing just went ballistic. Um, yeah, it was to do with mobile phones anyway. But it won't work now because they don't have antennas on them anymore. But this was, jeez. I'll never forget it. Talk about having your lunch cut. My God. Straight in, whack, got it. And I guarantee you too that even in some of the videos that I've done when I've shown how to do things, I've been told that there's people out there trying to copy what I've done and trying to do it commercially right now. So you'll see stuff turn up, and you'll know who came up with putting it up on the internet and saying, "Oh, this is how you do this, and you've got to do that." Da 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 da. You'll see it all, and you watch them take the credit for it, and then refer back to my videos. So it makes me sometimes second guess what I should put up online, what I should talk about. But there is some stuff I do not talk about. I'll tell you that right now. But you'll see it. You'll see it one day when I get enough time to properly launch it. So I have to set up. I'll probably have to set up detector shops too. Some detector shops, not all detector shops, will get my stuff. There's some detector shops out there, or detector personnel, as we'll say, that just want to badmouth you for whatever reason. I don't know what reason. They just want to do it. And like I say, I get this stuff told to me. They go in the little black book, and it'll never be offered anything. Even if it's the hottest things in sliced bread, they won't be offered it to sell. Just absolutely refuse. So it comes down to, don't piss me off, because sometimes that sort of stuff really sticks with me, and I don't like it. So bad luck for you guys. Most detective shops are really good. They really are. I do talk to people who own these shops and do things, but yeah, sometimes they're nice to your face and nasty behind your back too, which you find out. You do find out. So it's not a very closed up shop. There's a lot of chit chat goes on, you know, and you know, I'm not going to say the mechanisms of how it works, but you know, I don't know. You know, can you vet all your employees? Do you know who they are? Do you know, yeah, whatever. You know, you know how it works. Just don't say anything nasty. Just be polite, and you know, don't say things you don't know about. Don't discuss things and say it does something when it doesn't, or it doesn't when it does, or whatever. You know, this sort of stuff. And the best critics of all are the armchair critics. I'll tell you that right now. I've had a lot of experience with armchair critics, and yeah, people with a vested interest in the movement of their product or their stock will say things. And yeah, read between the lines, guys. Just read between the lines. You know, when I first started doing this, so many, I don't know, I could actually say decades ago, because it actually is. When I first started doing this stuff, even back then, it was, you know, well, Mind Lab was a different sort of company, a little bit different to what it was. Now, it started off really good, then it went really evil, and then it sort of pulled its head in a bit, in my opinion. Right? Because I know they have in-house counsel that love writing legal letters out. So, yeah, but like I say, at first they hated, absolutely hated anyone doing modifications on their detectors. They still do, obviously. That's why you lock up the whole front end in a block of resin, so you can't do it. But you know, that's not the be-all end-all. Crazy stuff. In my opinion, crazy stuff. Because what happens when that module fails and it's put in with about whatever 50 big steel copper pins? You got to cut it out and then remove them all. Oh my God! You know, the guys doing the warranty. Oh dear, what a time waste. You know, oh, in other words, if it was all open, they can say, oh, look at that resistor burnt out. Oh, because that transistor's gone now. No, we replaced a transistor and a resistor. Oh, we're up and going again. But no, got to replace the module, which are very expensive, so I'm led to believe. That's what I was told. That's my opinion on the subject. Yeah. So, and all these GPXs are really easy to work on. They're not hard at all. Really easy. GPs, all those SDs, GPs, whatever, they're all easy to work on. No problem. Even the later ones, you just can't get to the receive input modules because they're all, yeah, in a big block of resin. I'd love to get into the front end of a 6 or a 7, see what can be done. I really do. I think well, I'll tell you what, right now, even I do the 6s for people, they are so much quieter. Oh, and they detect better. They got better performance. You know, it's not just my opinions. Everyone's opinions made comments who's ever had one done. So, yeah. And speaking of that, I better stop yabbering. Done enough on that. I've got to get these out. I've got 7 sitting out there looking at me, and I've got someone going to unbox and see what needs doing, and we'll get it done. So yeah, got to give me voice arrest. So that's that, guys. I hope you can see the merit in doing things the way I've done here. That you know, trying to show it as it is and subjecting the poor things to the worst possible scenarios. That's the worst ground you'd ever find, ever. I mean, God, it's, you know, next thing I might do, I might actually, within that ironstone, I might put that on top of the big tub of Kalgoorlie dirt, and then I'll embed all my hot rocks and banded ironstone into it. I bet you I can still ground balance and pick up tiny gold. But anyway, that's probably enough. Catches.